With a good understanding of one of the most critical inputs to material requirements planning, the bill of materials, it is important that you understand that there are many different types of bills of materials. While we won't get into every detail of each of the bills of material, we will introduce a number of them. Some different types of bill of materials are single-level bill of materials, multi-level bill of materials, planning bill of materials, manufacturing bill of materials, engineering bill of materials, sales bills of material, and many, many more. In the upcoming modules, we will introduce each of these bills of materials to you. We'll see you in the next module. What is a single-level bill of material? A single-level bill of materials is one level of an assembly and does not include any lower-level sub-assemblies. It displays only one level of components that would be used in their direct parent item. In other words, a single-level bill of materials would only show the relationship one level down. It would not include grandchildren or any other relationships. Only the first level. A single-level bill of material is generally used on simple assemblies. These assemblies would not include sub-assemblies, only components. One layout of the single-level bill of materials is a document that contains every part that would be used in the build of the item. The listing would also be in order as there is only one single level. In a product tree format, you would only see one level down. As you can see, the basic structure of a single level bill of materials would only allow one level of children in the form of components, assemblies, or materials. Here we see a listing of a bill of materials for soup in both a simple listing format and a product tree format. As you can see, the broth is measured in gallons, and each of the item measurements are in each. You may also see other types of units of measure, even some that may show blank. One of the benefits of using a single-level bill of materials is that information or data for each of the components is stored in only one place in MRP. This makes it much easier for engineers to update the bill of materials, maintain numbers, and make changes if necessary. And that's it, a single-level bill of material. We'll see you in the next module. A multi-level bill of materials is the complete opposite of a single-level bill of materials. Multi-level bill of materials are used for more complex builds. These types of bills of material include components and sub-assemblies. In addition to this, sub-assemblies in a multi-level bill of materials are oftentimes broken down even further into more sub-assemblies. In these types of bills of material, the bill or document must show each item number and the parent it is associated with. Multi-level bills of material are almost always have more than two levels of a parent-child relationship. One unique thing to note about multi-level bills of material is that the information on the bill of materials is still generally stored as a single-level bill of material and tied together at the various levels. The components and subcomponents are tied together in the proper order according to the way they need to be built. Keep in mind that if an item is built in a single work center, It may make more sense to structure the bill of materials as a single-level bill of materials. Now that you know what a multi-level bill of materials is, let's look closer at two common types of multi-level bills. See you in the next module. Today we're diving a little deeper into the world of bill of materials to understand the indented bill of materials, or BOM. Let's explore what it is. Unlike a traditional BOM, which lists components in a flat structure, an indented bill of materials represents the hierarchical relationship between components, subassemblies, and the final product. It will show the highest level of a parent closest to the left side of the listing and all the components that are used within the parent item indented to the right. Any other levels that are shown are indented even further to the right depending on the proper build of the bill of materials. Keep in mind that if a component is used in a different place within the bill of materials, this component will be shown more than once under each of the subassemblies it belongs to. The primary purpose of an indented bill of materials is to provide a clear and structured way for your product's assembly. It helps in understanding the product structure at one single glance. Creating an indented bill of materials involves gathering information from various sources such as engineering drawings, CAD models, and product specifications. Accuracy and thoroughness are key in this process. Indented BOMs are used in various scenarios, including new product development, managing product variants, and supporting your supply chain management. Several software tools are available for creating and managing an indented bill of materials, including enterprise resource planning systems and product lifecycle management software. Many of these forms of software provide a way for users to expand or collapse the bill of materials. This makes it much easier to understand and look at the different levels closer. In conclusion, indented bill of materials play a crucial role in manufacturing and product management. Understanding their structure and importance is essential for streamlining production processes and ensuring product quality. We'll see you in the next module. Welcome back. In this module, we'll be delivering or delving into the summarized bill of materials. Whether you're a seasoned professional or just starting out, understanding this concept will help you. So let's dive in. First things first, what exactly is a summarized bill of materials? Think of it as the Cliff Notes version of a traditional bill of materials. While a detailed bill of materials breaks down every nut and bolt, a summarized bill of materials gives you a bird's eye view of the product structure. Essentially, the summarized bill of materials lists all the parts, quantities required, and other pieces of key information that you would need to build your item. One key difference is that the summarized bill of materials does not list the various levels of an item. In addition to this, it will only list items once, even if they are used in different places of the bill of materials. This is, as you may have guessed, is why it is summarized. So, why do we need a summarized bill of materials? Well, let's imagine you're a project manager tasked with estimating material costs for a new product. Instead of sifting through pages of detailed BOMs, a summarized BOM gives you a quick snapshot of the main assemblies and their quantities. And there you have it, folks, a crash course in the summarized bill of materials. Whether you're a seasoned pro or just dipping your toes into the world of bills of materials, understanding this concept is essential for streamlining your production planning process. So next time you're tackling a new project, remember the power of the summarized BOM. Until next time, stay curious and keep innovating. In this module, we're embarking on an exciting journey into the world of planning bills of materials. So grab your notepads and get ready to learn with me. So what is a planning bill of materials? The planning bill of material is just that. It's used for planning. This type of bill of materials is not real and focuses on an artificial listing of items that is used for purposes of planning. This type of bills of material helps with both master scheduling and material requirements planning. These planning bills usually show the historical demand as an average percentage. This helps the planner and the system to plan more accurately. Modular bills of material are a good example of a planning bill that is often used. Modular bills of material include modules. This means that the modules can be adjusted and moved around to plan appropriately. Planning bills of materials rarely include anything specific, as they are used for planning purposes only. This can be helpful especially when working with engineer-to-order, make-to-order, and assemble-to-order items. The purpose of planning bills is quite simply to simplify planning. And that's it. Thank you for joining us on this insightful exploration. Remember to stay tuned for our next adventure together. Until then, keep learning, keep growing, and keep exploring. Welcome back to the essentials of material requirements planning. Today we're delving into a fascinating topic in the bill of materials, the phantom bill of materials. It may sound mysterious, but understanding how to leverage it can greatly enhance your knowledge about the bills of materials. So let's dive in and demystify the phantom BOM. Let's start by answering the question, what exactly is a phantom bill of materials? Think of it as a virtual subassembly that doesn't physically exist. It's a way to group together related components without actually creating a separate physical assembly. The phantom bill is an item that will be part of the physical build, but will never be inventoried. For this reason, when a phantom is used, typically it is only on temporary items that are not stocked. When a temporary item is used in the phantom bill of materials, lead times can be set to 0, as well as the order quantity. As such, when material requirements planning runs its logic, it blows right through the phantom item and moves on to the next level of subassemblies, components, or whatever is another level down in the parent-child relationship. Now, why would you use a phantom BOM? Well, it serves several purposes. It helps simplify complex product structures, reduce manufacturing lead times, and improve inventory management by grouping together related components. With this in mind, let's break down the components of a phantom BOM. It consists of a parent item, which are the main assemblies or products, and the phantom items, which are the virtual subassemblies. These phantom items don't have their own physical inventory, but are instead exploded into their components during production. Phantom bombs are commonly used in industries with complex product structures such as automotive, electronics, and aerospace. They're particularly useful for managing modular products where different configurations share common components. Implementing phantom bombs requires careful planning and coordination. It is essential to establish clear naming conventions, documentation practices, and validation processes to ensure accuracy and consistency. Like any tool, phantom bill of materials come with their own set of challenges. This may include maintaining synchronization of the parent bombs, ensuring accurate cost calculations, and managing changes to the product structure. And there you have it, a comprehensive guide to the phantom bill of materials. By understanding its purpose, benefits, and best practices, you can optimize your bill of materials. So next time you encounter a complex product structure, remember the power of the phantom bill of materials. Until next time, happy manufacturing. Welcome back to the essentials of material requirements planning. Today we're delving into a fascinating topic in the bill of materials, manufacturing bill of materials. The manufacturing bill of material is also known as the MBOM or MBOM. It is used when a manufacturing company needs to display all of the components and assemblies that are needed to manufacture a finished product. This includes parts that need to be processed, painted, and transformed in any way. They are all shown in the manufacturing bill of materials. Like other bills of materials, the manufacturing bill is shared in enterprise resource planning systems, material requirements planning systems, and other forms of software. This is the most common type of bill of material used for a manufacturing company. And that's it, the manufacturing bill of materials. Stay tuned for the next module. In this module, we'll be discussing an essential aspect of engineering and manufacturing processes. The engineering bill of materials. The engineering bill of material is developed during the design phase of a product life cycle. These engineering bills of materials are often based on computer-aided design or electronic design automation tools. There are usually a few different components in an engineering bill of materials. These include the part number, the part name, and the description, the quantity of each component, the unit of measure, the reference designator, which identifies where the component is used in the assembly, the material and material specifications, which details about the material used and its specifications, suppliers and supplier part numbers, which generally provide information about suppliers and their part numbers. One unique thing about an engineering bill of materials is that it's actually quite common for more than one EBOM to be associated with one finished product. And that's it, the engineering bill of materials. Understanding the engineering bill of materials is crucial for efficient manufacturing processes. It ensures that the right components are procured, manufactured, and assembled to create high-quality goods. In this module, we're going to talk about a crucial form of the bill of materials, the sales bill of materials, or SBOM. A sales bills of material, or SBOM, is a comprehensive list of the components and items included in a product or service package that a company offers. SBOMs are created for three major reasons. The first is clarity and transparency. Sales bills of material provide customers with a clear breakdown of what is included in a product or a service package. The next reason is customer satisfaction. The SBOM helps in managing customer expectations by providing a detailed list of what they will receive. And finally, sales bills of material are created for sales process efficiency. This type of bill of materials facilitates the sales process by providing sales representatives with a clear understanding of a product's offering. One difference between a sales bill of material and other bills is that the sales bill of material provides details with regards to the finished product that can be seen in the sales phase of a product's life cycle. In a sales BOM, both the end item and all of the components will appear as separate items in the document. In addition to this, the parent item is always the only item listed as a sales item. The children or dependent requirements will be listed as sub-items of the parent item. A sales bill of material is an essential tool for businesses to effectively communicate products or service offerings to their customers. It provides transparency, clarity, and helps in managing customer expectations. And that's it. We'll see you in the next module. In material requirements planning, a sophisticated system of logic is used to efficiently manage information, data, and the flow of materials that is needed for production. One of the critical inputs of MRP is the planning factors. These planning factors are used by MRP to accurately calculate needed requirements for materials to meet the demands that are being placed on production. The planning factors also play a crucial role in determining when materials are needed and also how much is required to maintain an ideal balance between inventory levels and production needs. By effectively managing and maintaining the planning factors used by material requirements planning, a company can ensure that they have the right materials available at the right time to support their production needs. With this in mind, the key word is maintaining. Material requirements planning should be regularly gone through and go through data cleansing to ensure that all planning factors and inventory data is accurate. In the next few modules, we will review some of the key planning factors used in material requirements planning. Those factors are order points, lot sizes, and order quantities, lead times, and safety stock. There is also one indirect planning factor that we will look at, and that is the scrap rate. These planning factors are very important for the system to accurately calculate material requirements and ensure that planning is done correctly in order to meet your production needs. Let's look at each of the key elements in the next few modules.